Okay, for this next video, so we are still under the discounting method, okay, for the net present value. So before we proceed with the NPV, we will discuss first the concept of present value. So here, this is the amount that must be invested now to produce the future value. So we have here a question for you to understand better the concept of present value. So here, how much, or the question here is, how much must be invested now in order to earn $363 for 2 years, assuming that the interest rate is 10%. Or in other words, if you want to receive $363 after 2 years with 10% interest, how much should you invest today? Okay, so this is um, the question that we refer to the present value of your investment. So to compute for the present value, normally we use this formula. So P here is, this represents the present value that we need to determine. So that is equal to F is your future value, okay, divided by the quantity of 1. 1 here is the constant variable plus I. This is your interest rate. Okay, and then your T right here is the time period or the investment period. Okay, so if you will use this formula to solve for the question or the problem that we have mentioned in the first slide, so that is, okay, $363 divided by, okay, our discount factor. Okay, so 1 is the uh, constant variable, so 10% is our interest rate, and to right here is the investment period. So therefore, if the investor wants to receive $363 after 2 years with 10% interest, so he must invest $300 today. Okay, so this is the the present value. This one is our future value. So to continue, as mentioned earlier, this expression of 1, okay, divided by quantity of 1 plus I, okay, with raised to n is what we call the discount factor. So actually, for you to be able to compute the future, even the present or even the future values more, uh, I mean, to simplify, the computation of your future and present value. So there is actually a table provided. Okay. So we have the table for discount factors for various combinations of interest rate and number of periods for the investment. Okay, so this table is used so that your computation for the present and future values are simplified. Okay, so in the next slide right here, we have here the example. Okay, suppose our investment, okay, is for 5 years, for example. And then our interest rate is also 5%. Okay, so what discount factor should be used? Okay, so this is normally multiplied with the future value or the present values. Okay, depending on the case, okay, of your time value of money, okay, illustration. So again, for example, if our investment is 1,000 for 5%, okay, with 5 years investment period. So to locate the discount factor from the table, all you have to do is to first look for the number of years right here. This is the number of years that you will invest. So in our example, as mentioned, that's for 5 years. And then after that, we will also locate the percentage or interest rate right here. okay, in this row. So again, based on our example, as mentioned, that's for 5%. Okay, so we will trace and locate it. Therefore, for our illustration, the discount factor that we will use is 1.2763. So this table, by the way, is uh, this is for future value. Meaning to say, if you want to determine the future value of your investment, you will use this table. So this factor right here, which we have located a while ago, so this will be multiplied with the investment, okay, to determine your future value. Okay, by the way, this table is for single cash flow, meaning to say even cash flows, okay, throughout the life of the investment. So aside from the table for future values, we also have the table for your present value. So this is the to locate, the discount factor under this table. So the same procedure. So you locate first the number of period of the investment and then look for the interest rate. Okay, and that will be your interest or discount factor. So to continue, we will use this example or illustration, okay, for you to understand better the concept of present value. So for this one, we have uneven series of uh, cash flows. So meaning to say, every year, right here, the investor receives different amount of cash inflows. So for the first year, he receives $110, second year 121, and in the third year, it's 133.10. So that makes it uneven. Okay, and then what you're going to do is to locate the discount factor. Okay, so here, 0.909 is located at a certain rate. Okay, 11, no, 10%. I mean, okay. So in our illustration, we use the 10% rate. Okay, and then in the table, we only use 3 decimal points. So that's 0.909. Okay, that's one for the first year. For the second year, that's 0.826. Okay, and in the third year, based on our table, that's 0.751. Okay, so in this case, all you have to do is to determine the present value of this investment. So we have to multiply the cash receipt with its discount factor located from the table. Okay, so this is its present value. Okay, for the second year, the same also. And in the third year, okay. So meaning to say, the present value of the uneven series of cash flows is $300. So this is the same with that of our first illustration a while ago. If you or if the investor wants to earn $363. So if you are going to total this cash receipts, this equal to $363. Okay, so this is the future value of the investment. The present value is 300,000. Okay, so we just round this up to get the present values. Okay, so this is in the case if the cash flows is uneven. What about if our cash receipt is even? Okay, so in this case, for example, the cash receipts are $100 every year. Okay, so the same procedure, we will use the table to locate the discount factor. For this is again 10%. So for the first year, the same discount factor, okay, that we'll use until in the third year. So if you're going to total this discount factor, we have an annuity. This is what we call annuity discount factor, a 2.486. You can actually use this one We also have the table for this. Okay. So if you can notice, I am not discussing the full concept of time value of money because we will have that in the next videos. Okay, so we will just focus on the concept, okay, for the purpose of the net present value um, method later on. Okay, so to get the present value of $248.60, you can also directly use this discount factor right here. 2.486 times your cash receipt of $100. That is equal also to 248.60. So again, this is the case under the present value if there is even or uniform series of cash inflows, okay, that is being received. So, okay, where is my slide? Okay, so that's all for the present value.